Okay, so the next subtopic we have here is how to calculate the distribution function for discrete random variable. So in definition 3.4, if x is a discrete random variable, the function is given by, so we can see here we have capital F, this is the cumulative distribution function of x, and then we have here the function of t, where it is the value of the probability distribution of random variable x at t. Is called the distribution function or the cumulative of x. For negative infinity is less than x less than infinity. And then we have theorem 3.2, the cumulative distribution function of a discrete random variable x must satisfy the condition where the cumulative function of negative infinity equals to 0 and then the cumulative value of infinity equals to 1. Okay, so therefore, based on what we have learned just now, if A is less than B, then the cumulative distribution function of A is less than or equals to cumulative distribution function of B for any real numbers A and B. So we can work it out here. Probability of getting the value A less than or equals to x or less than equals to B equals to the cumulative distribution function of B minus the cumulative distribution function of A minus 1. And then the next one we have, if we are going to calculate the probability of A less than x less than equals to B, so we can calculate it by calculating the cumulative distribution function of B minus the cumulative distribution function of A. And then the last one, if you want to calculate the probability of x equals to A, therefore you only need to calculate the cumulative function of A minus with the cumulative distribution function of A minus 1. So let's take a look at example 3.4. In example 3.4, the question, find the distribution function of the total number of heads obtained in 4 tosses of a balanced coin. So we have 4 coins here. We only have 1 coin, but then we are going to choose it 4 times. So based on the solution, so I already tell you how to develop this table using tree diagram before this, so please refer to the previous video. So after you calculate all the probability, so when x equals to 0, the probability distribution is 1 over 16. So if you are going to calculate the cumulative distribution function where x equals to 0, so we only need, since the lowest value is 0, so the cumulative distribution function is equals to probability distribution of x equals to 0. Therefore, the value is 1 over 16. But then if you are going to calculate the cumulative distribution function of x equals to 1, therefore the value, since the lowest is 0 and then the next number is 1, so you need to cumulate the value here. So the probability of distribution function when x equals to 0, you need to plus it with the distribution function, the probability distribution function when x equals to 1. So since when x equals to 0, 1 over 16, x equals to 1, 4 over 16, so the value is 5 over 16. So the same things repeatedly happen to the next number. You only have to total up everything. If you're going to calculate the cumulative of x equals to 4, so that means you need to add up every number before that. So before 4, we have 3, we have 2, we have 1, we have 0. So by right, if you're going to total up everything for cumulative distribution function when x equals to 4, the value is 1. And then when the cumulative distribution function of x equals to 3, so when you total up x equals to 0, 1 over 16, plus x equals to 1, 4 over 16, plus 6 over 16, plus 4 over 16. So you're going to get 15 over 16. So the same things happen when x equals to 2. So the cumulative distribution when x equals to 2, you need to total up the probability when x equals to 0, which is 1 over 16, plus 4 over 16, plus 6 over 16. So the value is 11 over 16. So after that, you need to write the distribution function like this. So this is your final answer. So the cumulative distribution function when x less than 0, the value is 0. Because in this table, we can see here, the lowest value is 0. So if you're going to calculate x less than 0, you are not going to get any value on that because it is 0. Because the possible value, this is a distinct value. You only can get either 0, 1, 2, 3, or 4. So if you want to get value less than 0, so it is quite impossible. So that's why the cumulative distribution function for x less than 0, the value is 0. But then if you're going to calculate the value of 0 less than equals to x less than 1, the value is 1 over 16. So this happened, the explanation is exactly the same for the rest of the equation. Okay, so let's try example 3.5. So there are 2 socks are selected at random and removed in succession from a drawer containing 5 blue socks and then 3 red socks. So we have 5 blue, 3. So first of all, you need to develop this table, or maybe if you prefer to use tree diagram, you can draw your own tree diagram. So blue or red. Then you're going to take this blue BR. So the probability of getting blue 5 over 8, and then this one 3 over 8. So this one is 4 over 7. So this one is 3 over 7. So please refer to chapter 2, probability chapter, if you don't really know how to draw a tree diagram. So this one, blue, the probability is 5 over 7. So this one is 2 over 7. So the element of sample space right here, the first one we have, let's say if you're going to get 2 blue. So 2 blue, 5 over 8, 4 over 7. So the value is 20 over 56. So the next one, if you get blue and then red, so the value is 15 over 56. And then RB, 15 over 56. And then 2 red color socks, you're going to get 6 over 56. Okay, so I forgot to define the random variable. Y is actually the number of blue socks selected. So you can see here, y equals to 2 because we get 2b. So there's only one b here, that's why it is 1. Also 1, and then no blue color, so it is 0. Okay, so for the first one, if you're going to calculate the cumulative distribution function when y equals to 0. So when y equals to 0, we only have one situation here when y equals to 0. So the value is 3 over 28. If we're going to check this and then if you're going to calculate the cumulative distribution function when y equals to 1, so that means you need to total up the value for probability distribution when x equals to 1 and when x equals to 0. So when x equals to 0, the value is 6 over 56. Plus the probability when x equals to 1, the value is 15 over 56 plus 15 over 56. Why I total up? Why there are two 15 over 56? Because the possibility when y equals to 1, there are two possibilities here. So we need to total up everything so that we can get the exact value. Equals to, so you need to 6 plus 15 plus 15. So 36 over 56. Or we're going to get 9 over 14. So for the last one, for the cumulative distribution function when x and when y equals to 0, since the possible value that we can get here is only 0, 1, 1, or 2. So you only need to total up the probability for x equals to 0, x equals to 1, and x equals to 2. So the value we get here is 6 over 56 plus 15 over 56 plus 15 over 56 plus 20 over 56. 1. Okay, so as usual, you need to write it like this function over here. So the cumulative distribution function of y, when y less than 0, is it possible to get y less than 0? So is it possible for you to take 1 socks and then you get actually less than 0 socks? So it is quite impossible, right? So there is no random variable here. The value is less than 0. So the value is 0. But then for the cumulative distribution function of 0 less than equals to y less than 1, the value is 3 over 28.